This video is about a sound-activated relay switch. We'll take you through an exciting DIY electronics project from start to finish, building a DIY sound-activated relay switch, also known as a clap switch. This project is perfect for those who need a smart sound-responsive circuit that can control other devices. This video tutorial is divided into two parts. In the first part, we'll guide you through the step-by-step process of building your own sound-activated switch. The second part will delve into the technical aspects, explaining how the circuit works and the role of each component. Gather all necessary components for the sound-activated relay circuit, including any general-purpose NPN transistor like C945, some quarter-watt resistors, capacitors, a 12V relay, and a condenser microphone. Refer to the schematic for exact values and quantities. Place each component on the PCB, according to the schematic, starting with smaller parts like resistors and diodes, followed by transistors, capacitors, and the relay. The circuit is designed to detect sound, amplify it, and when the amplified sound exceeds a certain threshold, it triggers a relay. This relay, in turn, can control various devices like lights, motors, or alarms. Sound-activated relay switch offer a range of possibilities, from practical home automation, like controlling lights or appliances with specific sounds, to enhancing security by triggering alarms, or cameras based on unusual noises. For those seeking fun and creative projects, sound-activated relay switch can bring interactive toys and games to life, responding to sound cues in exciting ways. Want to build your own sound-activated relay switch? Leave a comment below with provide PDF file to get the complete project details, including the circuit diagram and PCB layout. And I will share the PDF link in your reply. Now it's time to tidy up. We'll trim any excess wire length from the components and then carefully solder each connection to ensure a strong and reliable circuit. You can trim the excess wire length from the components before or after soldering, whichever you prefer. Both methods will work just fine. With all the components soldered securely, your sound-activated relay switch is ready to be powered up and tested. Now, let's bring our circuit to life. We'll connect a 12-volt power supply. However, to fine-tune the sound sensitivity, we'll need to adjust the potentiometer. We'll aim to set it so that a single clap turns the bulb on, and a second clap turns it off. Now that our sound-activated switch is built, let's dive into the science behind it. We'll break down how the circuit works, from the microphone capturing sound to the relay activating the device. Microphone input. The circuit starts with a condenser microphone that picks up sound signals. This microphone converts sound vibrations into an electrical signal. Amplification stages. The signal from the microphone is very weak, so it is fed into a series of transistor amplifiers to boost the signal. The transistors amplify the audio signal so that it can be used to drive other parts of the circuit. Sensitivity adjustment. A variable resistor VR1 allows you to adjust the sensitivity of the circuit. This lets you control how much sound is required to activate the relay. Signal processing and switching. After the audio signal is amplified, it reaches a flip-flop arrangement created by transistors and diodes. This flip-flop circuit ensures that when a sufficient sound signal is received, it will toggle the output state of the relay. Relay activation. The amplified and processed signal finally triggers a relay through another C945 transistor. When the relay is activated, it can switch external circuits like turning on and of an appliance. The relay has contacts labeled No normally open and NC normally closed that change state when activated. Want to build your own sound-activated relay switch? Leave a comment below with provide PDF file to get the complete project details, including the circuit diagram and PCB layout. And I will share the PDF link in your reply.